launch our TensorFlow task on the cloud. So I'm gonna show you how to use it using some examples. So all the source code that I used in this slide is in here, so you can just download. And basically, I assume that you have some ideas about what is cloud computing and Google Cloud, and then you also probably have one account. If you don't have, don't worry, you can just go there and create one account today. Also, I assume that you have some experience of using TensorFlow in your local machine. Basically, you can build deep learning models using TensorFlow usually, and then you probably load a lot of training data to your model, TensorFlow model, and then you spend some time to train it, and then the result will be saved back to the local disk. So one issue here is that usually TensorFlow, it depends on what kind of task, what kind of training, but usually it takes a really long time to train a decent model. So often this task requires very powerful machines with multiple GPUs. But using Google Cloud ML, probably what you can do is that without even having powerful machine, you can just put this TensorFlow task to the cloud, and then you can use all the powerful machines in the cloud, and then execute the training task in the cloud, and the all result then will be stored in the Google storage, which is also in the cloud. This is a basic idea of the Google Cloud ML. Before we actually jump into the example, we need to set up our environment. There are several ways to set up our environments. So first of all, I think I really prefer this way. So basically you can set up this whole environment in your local so that you can develop the TensorFlow models in your local machines, and then you test a little bit, and then you can submit your job to the Google Cloud. So this is one way. So you can go down and check it out. Another very easy way is that you can just simply use the Cloud Shell. So in this video, I'm briefly show that because it's so simple. So just to log into your console, and then in this corner, you see this icon, which you can launch Google Cloud Shell, and you just click it, and then you probably can see this shell interface. And this is, I think, it's based on one of the Debian. So good thing about this Google Cloud Shell is that all basic environments are already set, and all necessary tools are already installed there. So additional setting up for the Cloud ML is so easy. So only basically 3 steps. Actually, there is only 1 step. Once you open the Cloud Shell, you just type this command line. Basically, it downloads a shell a script, and then we just execute it. And then after finishing this one, what you can do is that you can just set the path so that you can execute some program which was installed by the second step. But once again, if you want to install something in your local, you can just follow this document. And then it has a few more steps, about 8-9 steps, but it's more or less similar idea. So you can easily set it up. And then once you set it up, the environment, you can test that all the environment setting is correct, also using this one single command. So you can download this environment checking Python, and then we can just execute this one. And then once we finish this setting, and then you see success from this command, then you can actually move to the next stage. The next stage is that in order to submit a task from your local or your Cloud Shell, it requires a certain access. So you have to allow this access by using this command, gcloud beta ml and init project. Then it will ask us a few things: what kind of project you are using, what kind of account you're gonna use. Just follow that, and then it will be easy to set it up. And then after finishing all this, the last setup is that having Google storage. Basically, all the tasks you execute in the cloud will be stored in the Google storage. And then also you're probably gonna read some training data from the storage. So you have to set up the storage, which we call the bucket. So the idea is that here we can automatically figure out what is your project name using some script like this, and then you can, using this project ID, you can set the bucket name. Or maybe if you want, you can just give a simple bucket name. And then once you have this set, you use this variable, and then we can create a bucket using this command called gs, Google Storage Util. MB means that make a bucket, and then this is a region, and then you can create this. In this, usually when you see something gs and // this actually indicates that the this location, this URL is actually in the Google Cloud, Google Storage. So in summary, actually what we did in this setup is that we basically installed two command lines and corresponding setups. So here Google G Cloud is basically command line interface for all the Google Cloud platform, including Cloud ML jobs and computer engine and so on. And the second one we installed is that called the GSUtil. It's another command line interface to manage the Google storage. Then now we can actually move on to the examples here. Once again, you can download all the examples from this GitHub repository. Once you download it, you can see some files and directories like that. First, you want to see that there is a module called the train. Inside of this, we have 3 examples here that I'm gonna go over one by one. And then there are 2 directories called input and output, which have the input data, and then the output directory will save the outputs of this TensorFlow task. So let's start with a very simple TensorFlow task, which is a very simple multiplication. So let's look at, so we're gonna basically run this run training, and then it has x, which is a placeholder, and w is a TensorFlow variable. And then y is a TensorFlow operation, basically TensorFlow dot multiplication of w and x. It's a very simple model. And then once we have that, we just start the session, and then we initialize all the variables, and then basically we executed this y, we evaluated this y, and using this x placeholder. So in this case, is when we evaluate this y, we're gonna feed the real value. So this is TensorFlow's way to execute some operations by passing arguments. This is sort of arguments. Very simple model. And then we can test this one locally. So one thing we should know is that before we send the task, submit the task to the cloud, always test something locally, and then make sure that it's running okay, and then you submit. So this is how we're gonna run this TensorFlow task in locally. It's very simple. Using Python, then we're gonna use module option, and then provide the module name. That's it. And then as we expected, so in the source code, basically you see we print out 2 things. So we see 5 and 10 as expected. It's very simple. And then now what we want to do is that we want to execute this task on the cloud. So the model is we just submit it, and then the cloud will automatically execute. So in order to do that, we have to set up some variables. First, we have to set up job name. So what is our job name? Maybe task 1, task 2. So you name it. And then we need a special bucket or a special location called the staging bucket. So here, using this project ID, also we set this staging bucket. What is this? Basically, the idea is that you work on your TensorFlow program locally, and then when you submit, what happens is that they're gonna submit your source code to the cloud, and they're gonna execute this source code in the cloud. Then, where should we copy the source code? That's called the staging area, staging bucket. So you have to specify where we're gonna send this code. And then once we have that, basically the submitting a task is very easy. So you're gonna use gcloud commands. Because the service is beta, we're gonna use beta, and then the service name is ML. And then jobs, and then we're gonna submit, and then this is training job. So this is sort of a really long command line, but this is always we're gonna use for this training. And after that, we're gonna provide what is the job name here, and then we're gonna say what is the path, and then what is the module name, and then here important thing is that we're gonna provide a staging bucket. This is the option that we need, and then we just execute this command line, and then we'll see some outputs, something like that. So when this was created, and then what's job ID, and then what is current status, which means here it's queued. So it's a queue inside of the cloud, so it will be executed when it gets chance, right? Then how we're gonna see the current states of this job? So one way is that you can just go to the console, and then there's a menu. Then you press the menu, almost the bottom, you can see the menu called the machine learning. And then once you select this one, you can see two sub-menus, which is model and jobs. You can select the jobs, and then you can see the all jobs that you executed. And then you can select one of the jobs, and then see more information here. And then the most important thing is that you want to see the logs, especially you have some error messages in here. You want to clearly see what is going on by looking at the logs. So one example, this is our logs, and has some warnings, but here you see all the printout that we had in our TensorFlow code will be here. So here in this case is 5 and 10, so which is expected. So it says, oh yeah, we correctly execute this simple multiplication model in the cloud. And then usually what we need is that we need to, in order to train our deep learning model using TensorFlow, we need a lot of training data. It's a lot of data. So for somehow we have to read this data somewhere, and then we have to train our model. And then where are we gonna read it? So let's say we are going to run it locally. So don't worry about the cloud. So just local. And then let's say we have one file called input.csv inside of the input directory. This CSV is very simple, so 1, 2, and 3, 4, 2 columns and numbers. And then here, in order to read the CSV, we're gonna use TensorFlow APIs. TensorFlow provides ways to read some content from file, including CSV, so you can find more information in this URL. But here, let's look at it. Basically, the idea is that, the file name is input.csv, and then from this directory, we're gonna read. It can be multiple files, so we're gonna put in the queue, and then we're gonna read these ones using this API, TensorFlow APIs. And then because this is CSV, we're gonna decode this one to CSV, and then we got the call 1 and call 2. And then how we're gonna read this one after opening session. Inside here, we basically execute this column 1 and column 2. Those are basically tensors. We execute them, and we get the numbers one by one. And then this number we just feed to our like a multiplication program. It's simple. All other parts are basically the same. And here one thing we need to decide is that where is the input directory. So we're gonna get that as a flags argument. So this input dir, default is input. So this is a very simple program that we're gonna read that from local, and then we do something from the CSV. And the really good news is that because all TensorFlow APIs provide GS location, so Google storage locations, once we have something like this, we don't have to change anything about the source code. So this code can either run locally, and then also we can feed the directory as a Google storage path. So first of all, let's try to run that locally. So once again, we assume that we have a file input.csv in this location, and then we just execute this one. So default input directory is the input, so definitely we'll read this one, and then we'll execute this program. So we have these values, 4 values as we expected. Now what we want to do is that we run this same task on the Google Cloud ML. So idea is simple. So we're gonna copy this one, automatically submit this task here, and this task will read the info CSV from this Google storage first, and then we'll execute. That's the basic idea. Then we need to some sort of a setup. First, like before, we're gonna have a job name, task 9, and then we have the staging bucket, which is the same as the previous example. And here, in addition, we're gonna have input path. So we're gonna use the staging bucket, and then only difference is that we have a folder called input. That's our input path. And then once we have that, we have to copy the CSV file to the Google storage. So this is command that using gsutil we can copy from our local to our Google storage. So once we do that, you can see some messages here, and then this was completed, right? Or another option is that you can just go to the console, which there are menu called the storage, and then we can select our bucket. Once we select our bucket, you can go that directory, and then you can either upload these files or something like that. So there are two ways, using just gsutil command line, or just directly go to the web interface and console, and then you can do that. Once we have finished it, so what we can do is that we can just run our gcloud command to submit the task. So the idea is exactly the same. So we're gonna run this long command line, and then provide the job name and the package path, and then staging buckets, and provide the module name is more or less the same. And the very important thing here is that once we have these two dashes, which means that after this, everything from here is the option for my TensorFlow task. So our TensorFlow requires the input directory. So in this case, this input directory is our Google storage bucket. So we're going to provide that. And then we execute that. Basically, we're going to have the same feedback like this. And then one thing you want to see is that the arguments for our program is this input directory with this Google storage path. And that's basically it, because we use the TensorFlow API to read the files. They automatically understand these directory names, and they can read the files from this location. And then we can check everything is okay in the jobs. We go to the job, and then we can see, especially see the logs, and then see the outputs. Here, as we expected, we have 4 outputs as we learned in the local. So it means that, oh, it's perfect. So basically read from Google storage and then executed this TensorFlow task correctly. And our last example is the output part. So once we have a lot of trains, then how are we gonna put the models in the Google storage? So basically the idea is very same. So as long as you are using TensorFlow APIs to save something, then you don't have to really change anything, because the directory you can directly feed gs:// as the bucket name, then TensorFlow will automatically take care of it. So one example here is that this is very common example. So we're gonna use the Saber, which is TensorFlow trained Saber, to save all the models in this session. And then in this Saber, first of all, we're gonna define what is the file that we're gonna use. And then here we use the ospath.join, and then this, assuming that we have an output directory, and the name of the file is checkpoint. And then we're gonna save the session into this file, right? This is once again TensorFlow API to save the file. That's basically it. And then here, one thing is that we're gonna get this output directory as an option. The default is just the output. Then we're gonna execute this one locally and see everything is okay. So we're gonna execute this one Python -module with this option, and then see we have the result that we expected. And then now one thing we want to check is that outputs are there. So we look at this directory. Then as we expected, we have a checkpoint files in here. So it means that we successfully, this TensorFlow task successfully saved all the outputs in this directory. And then how are we going to run this one into the Google Cloud ML? Basically, the idea is the same. So first, we need to set up something here. So it's like what's job name, and then staging the same. We have to define what is the output path, where we're going to put these checkpoint files. So here, once again, we're gonna use this bucket, and then the directory is called output. Folder is called output. And before we execute this task, first of all, we need to make sure that this folder is created. So GSUtil, unfortunately, they don't have any direct command to create a folder. So one idea is that we can just copy empty file to that path. When you do that, make sure that this path ends with a trailing slash like this. Then it will create a directory. So this is one way. Another way is, once again, you can go to the console and then you can create a folder using this method, or you can double check that we already have that folder. Otherwise, you get some error messages. And then once we set these variables, and then we create this directory in our bucket, we can just execute that program exactly the same way. So here is a long command line, and then we provide job name and packages and so on. And the one thing you want to pay attention here is that once we have two dashes, these are our options. We just define where is the output directory. So we put this output path. And that's it. And then we can just wait a little bit and then go to the console again, and then you see the job is completed. In this case, this task will create some output files. So we're gonna go to the storage console and then see we have that file inside. So go to that bucket and then go to that directory. Yeah, as you see, we have these checkpoint files as we expected. So it means that our TensorFlow task successfully stored all the session information in this directory. So you can download this one for your services, or using this one you can continuously train your models. So this is a really great service. So because you can just submit your task, you don't have to worry about the servers, because this is a serverless environment, something similar to Amazon Web Services called Lambda. So you don't really have to worry about, oh, should I turn off this GPU, very expensive machines. If you don't turn off for several days, it will cost you a lot. But here, you don't have to worry about it. Unfortunately, however, this great power usually comes with some responsibility, right? So in this case, it's the cost. So it's not free, so you have to pay based on your tiers. So in this case, it's not too expensive. So you want to double check that the price. So I think it's a really good idea to, whenever you log in to Google Cloud, check your bills, and then usually I'm very happy to see this 00, right? So, or maybe you have some expected budget, double check that this is exactly what you are expected. So briefly covered very simple examples how to use Cloud ML here, but Cloud ML can provide many more things. So for example, Cloud ML, using this Cloud ML, you can deploy your services predictions on the cloud without any server. And then in the limited hyperparameters like number of layers or running rate can be automatically tuned using this Cloud ML. And then lastly, I think very important thing is that even we can run our TensorFlow task on the distributed environment using this Cloud ML. So a lot of Google services, real services, that are actually using this Cloud ML for the training. So we basically have the same power that Google has if you can use them wisely. But unfortunately, this is a little bit complicated, so I'm gonna make a separate video for this.